Alright, let's have a look at this compass rose style figure. Symmetry is all about balance, how a shape can be folded or turned while still looking exactly the same. Let's break this down into two parts: lines of symmetry and rotational symmetry. Part A is asking to find the number of lines of symmetry. A line of symmetry is like a fold line. If you were to place a mirror on that line, the reflection would perfectly match the other side. Looking at our figure, we can find these lines by looking at the arrows. You can draw lines straight through the points of the north-south, east-west, and diagonal arrows. That gives us 4 lines. You can also draw a line exactly halfway between each arrow. If you fold the shape there, the arrows on the left will land perfectly on the arrows on the right. That gives us another 4 lines. Therefore, the total lines of symmetry are 4 plus 4 is equal to 8. Moving to part B. Rotational symmetry is about how many times a shape looks normal as you spin it around its center point for one full 360-degree turn. First, we look for the order. Since there are 8 identical arrows spaced evenly around the circle, you could rotate this shape 8 times, and each time an arrow would land where the previous one was. Therefore, the order of rotational symmetry is 8. In math, the word degree usually refers to the angle you have to turn the shape before it looks the same again. To find this, we take a full circle, 360 degrees, and divide it by the order. So, the degree of rotation equals 360 degrees divided by 8. This is equal to 45 degree per rotational symmetry. However, in this question, although they use the word degree, but they only want the order of rotation. So our answer is 8. Ready for the next question? Let's go! Let's have a look at this question, which asks about the lines of symmetry for a square. Now, a line of symmetry is like a folding line. If you fold a shape along that line, and the two halves match up perfectly, then you've found a line of symmetry. For a square, we can find exactly 4 lines of symmetry. Let's break down where they are. First, we can cut the square right down the middle in 2 ways: vertical, from top to bottom edge, and horizontal, from left to right edge. If you fold the square along either of these lines, the edges will meet perfectly. Because a square has 4 equal sides and 4 90-degree corners, we can also fold it from corner to corner. The first diagonal is from the top left corner to the bottom right corner. The second diagonal is from the top right corner to the bottom left corner. So, we end up with a vertical, horizontal, and 2 diagonal lines. Remember, this only works for a square because all sides are equal. Ready for the next one? Let's go! Let's have a look at this question about rotational symmetry. The question asks for the degree of rotational symmetry for the plus sign, or cross, shown in the image. Let's break this down into simple steps, so you can solve this for any shape. Let's start by understanding the concept. Rotational symmetry is what happens when you rotate a shape around its center point, and it looks exactly like it did before you started. Imagine pinning the center of the shape to a board and spinning it. Now, the question is asking for the degree of rotational symmetry. This is another way of saying, how many times does the shape look like itself during one full 360 degrees turn? We will start by looking at the vertical bar. If you rotate the shape a quarter turn, the vertical bar becomes the horizontal bar. It looks exactly the same. This is our first rotation. Let's rotate it again. Now it's upside down, but because it's a cross, it still looks identical. This is the second rotation. Now rotate it again, it will be horizontal, and that will be our third rotation. And the final rotation will take you back at the start. This is our fourth rotation. So, the order of rotational symmetry for this shape is 4. Now, the question asked for the degree of rotational symmetry. However, they meant to ask for the order of rotational symmetry. Let me explain the difference between both. To find the degree of rotational symmetry, which is the smallest angle you can turn it to make it look the same, we use a simple formula. Angle of rotation equals 360 degrees divided by the number of order, which we found earlier. Since our order is 4, we do the math. 360 degrees divided by 4 is equal to 90 degrees. The degree of rotational symmetry for this shape is 90 degrees. This means every time you rotate the cross by 90 degrees, it fits perfectly back into its original outline. So, if you ever get stuck, just count how many identical points the shape has pointing away from the center. For a regular cross like this, there are 4 arms, which usually tells you the order is 4. Ready for the next question? Let's go! Let's have a look at this question about reflectional symmetry. Our goal is to take this shaded block and make it perfectly balanced in 4 different ways by adding only 2 more squares. For a square-shaped figure like this to have 4 lines of symmetry, it must look the same when you flip it over. We will have a vertical line down the middle, where the left matches the right side, a horizontal line across the middle, where the top matches the bottom, and 2 diagonal lines connecting the opposite corners. To start, we need to find the center of the shape. Looking at the grid, the shaded area forms a 6 by 6 outer square with a 2 by 2 hole in the middle. The center point is exactly in the middle of the white hole. Imagine folding the grid along the middle vertical line. Does every shaded square have a twin on the other side? Look at the top right corner. The top left corner is shaded, but the top right corner is empty. That's our first square to shade. Now imagine folding it horizontally. The top edge of our shape is solid, but the bottom edge has a gap right in the middle. That's our second square to shade. Once you shade those 2 squares, let's verify. Looking at our vertical line, the left side is a mirror image of the right. Looking at our horizontal line, the top half is a mirror image of the bottom. Finally, looking at the diagonals, if you fold it corner to corner, all the blocks line up perfectly. Ready for the next question? Let's go! Let's take a look at this question together. We are looking for lines of symmetry. Think of a line of symmetry like a fold line. If you can fold a shape along a straight line and both halves match up perfectly, then that line is a line of symmetry. Let's look at our 4 shapes one by one. Look at this 4-pointed star. Imagine drawing a line straight down the middle from the top point to the bottom point. If you folded it, would the left and right sides match? Yes. Vertical lines match perfectly. Horizontal lines matches perfectly. It even has diagonal lines of symmetry. Therefore, this shape definitely has 1 or more lines of symmetry. Now look at this house-like shape. Notice how the roof points to the right, and the top side is shorter and slanted differently than the bottom. If we try to fold it horizontally, the top and bottom won't match. And if we try to fold it vertically, the pointy end has no match on the left side. Therefore, this shape has 0 lines of symmetry, and we call this shape irregular shape. Check out this arrow. If we draw a horizontal line right through the middle of the shaft and the tip, what happens? The top half of the arrow is an exact mirror image of the bottom half. If you folded it over that middle line, they would overlap perfectly. This shape has 1 line of symmetry, which is a horizontal line. Looking at the last shape, at first glance this looks like a rectangle, but look closer. The left side is shorter than the right side, and the top is slanted. Because the sides are different lengths and the angles aren't square, no matter where you try to fold it, the corners won't meet up. Therefore, this shape has no lines of symmetry. To solve this question, the 2 shapes that have symmetry lines are the 4-pointed star and the arrow.